Hello and welcome to another edition of Sparky Help, this time looking at RL circuits in series. That's resistance and inductance in a series circuit when connected to an AC supply. Please like, share and subscribe. Thank you very much. Our circuit then, we have a resistor, an inductor connected to a supply as shown. And what have we got to do? Well, as always, better to work from an example. Determine the following. Let's work out the inductive reactance, which is measured XL, impedance, total current, VL, VR, so that's the voltage across the inductor and the resistor, and the total power in watts, and also the power factor, and draw the phasor diagram, or you could be just sketch the phasor diagram. So let's start off with the inductive reactance XL. What do we need to do? We need the formula. XL is 2 pi FL. We put that into our calculator and that's 2 times pi times 50. The frequency 150 times 10 to the minus 3 because it's in milli. Or you could just put 150 and divide by 1000. Put that into your calculator and that comes to 47.12 ohms. That is the inductive reactance. So that's the first part done. What's next? The total impedance. Impedance is measured in ohms again, is the total opposition to current flow. For that we have this formula. Can't literally just add them because they are out of phase. So therefore we do 45 squared, which is the resistance, plus 47.12 squared, and then square root your answer. This is just Pythagoras. Check out my video on Pythagoras and trigonometry. And that comes to 65.16 ohms. That's the entire circuit then opposes the current by that amount of ohms. And that's Z complete. How do we work out the current? Well, we use the old tried and tested formula of Ohm's law. So it's voltage divided by the ohmic value. In this case, we divide by Z. So 230 volts divided by 65.16, that gives us 3.53 amps will flow round this circuit. So that's that one done. Work out the voltage across the inductor. So that's again Ohm's law. I times an ohmic value, not R because it's XL, that's the ohmic value of that inductor. So that's 3.53 times 47.12 and that gives you 166.3 volts. How do you work out the next one? Well, I think you're sort of sussing it really. It's Ohm's law. V equals I times R. And you know it is R because it is a resistor in this case. So 3.53 because current in a series circuit stays the same, multiplied by 45 gives you 158.85 volts. And that's the voltage across the resistor. Total power for the circuit. Well, there are 3 power formulas that you could use, however my favourite is always I squared R in this case, because the only bit that's going to use power up there is the resistor, so without further ado, I squared times R. 3.53 times the resistor, which is 45, and that gives you 560.7 watts, so this will produce and heat energy of up to 560.7 watts. So that's that part done. Work out the power factor. Power factor R over Z. We have our R, which is 45, and we have our Z. So we just divide one by the other. If you get a number higher than 1, then you've got it wrong. So 0.69, and this is a lagging circuit because it is an inductive circuit, and we refer to what the current does. So there's our power factor for the circuit, 0.69. Last part that was asked for was draw the phasor diagram. I've done this to scale. Obviously you won't be able to do it look at it from the screen, but when I made it, we remember the term civil and the last 3 letters volts leads current in an inductive circuit. So we draw current as our reference because that is common to both components, and that goes in an anti-clockwise direction in a rotation that is so many radians per second. In other words, the frequency, but it's omega or 2 pi f, which basically turns it to radians per second, but not you need to know that, but that's what it does. Across in phase with that, we have VR. And out of phase by that, we have VL. Remember, volts leads current. So there's VR, 158.85, 166.3. And if we add these up as a phasor representation, because they are out of phase, effectively trying to draw a parallelogram of that, and we get Vs, which would be 230 volts. And the angle, if you do cos to -1, will give you 46 degrees. And if you drew this to scale, you could then get a protractor and measure that. So, there you go. That's how to do an RL circuit. This is Sparky Help. Thank you very much.